After watching this video, you'll be able to recognize the benefits of working DevOps, describe how Taylorism is not beneficial for software development, and recognize that software development is more like craft work than factory work. In order to change your culture, you must change the way that people work. Working DevOps is all about facilitating a culture of teaming and collaboration. It's right from the Agile Manifesto. We value individuals and interactions over process and tools. Establishing Agile development as a shared discipline is at the core of building a strong DevOps culture. You also want to automate relentlessly to enable rapid DevOps responses. Sometimes automation is all people think about when they think about DevOps, but DevOps is not just about automation. But in order to respond rapidly, you must automate. Building a culture in which doing tasks manually is frowned upon and automating tasks is rewarded is the culture you want to have. Pushing smaller releases faster so that you can measure and remediate impact is also extremely important. We want fast feedback loops, and one way to achieve that is with frequent, smaller releases. This minimizes risk and maximizes learning. The problem we're up against here is that we've been working the same way since the Industrial Revolution. This is known as Taylorism. Taylorism is named after a U.S. industrial engineer, Frederick Winslow Taylor, and his 1911 book, Principles of Scientific Management. Taylor laid down the fundamental principles of large-scale manufacturing through assembly line factories. During the Industrial Revolution, Taylor established the adoption of command and control management, which has become the dominant method of management in the Western world. He also prescribed that organizations be divided into independent functional silos. Taylor watched how workers executed their jobs and realized that if workers were separated into task-specific roles, they could gain greater efficiency. This assembly line concept grew from this, right? For example, workers would just put on the doors of the cars, and the next worker would just put on the windows, and so on down the line. And this was faster than one worker tooling up to put on a door, then retooling to put on a window, and then tooling up for each stage of the assembly. One of the impacts of Taylorism that we see in business today is this idea of decision-making separated from work. In other words, managers do all the planning and decide what the workers should do, and the workers mindlessly do the tasks. They are told what to do. Many projects are still managed this way today. You can see the impact of Taylorism on information technology today. We have project management that is at the top of command and control food chain. Project managers give the directions. Architects design the systems and hand off to the developers to code. Developers hand off to testers. Testers hand off to operations. Operations hands off to security. Each performs a task-specific role in their own silo, with each handoff being an opportunity to make mistakes, lose context, or cause bottlenecks. Optimized roles may work well for making cars on an assembly line. It does not work well for software development. Automobiles are made up of standard parts. In software development, most of the parts don't even exist yet. If they did, we'd buy them off the shelf. The fact that we have to write the code ourselves illustrates that this is bespoke. This is customized or specialized. Software development is considered knowledge work. It's also craft work when you think about it. It's creating a one-of-a-kind application that doesn't exist yet. When you make automobiles, you tool up to make hundreds or thousands of them. That makes the rigor of tooling worthwhile. In software development, you're making one application. Why would you tool up an entire assembly line to make one of something? It doesn't make sense to treat software development like a factory assembly line. Steve Jobs once said, "It doesn't make sense to hire smart people and then tell them what to do. We hire smart people so they can tell us what to do." Managers need to be able to trust that they've hired the right people, let them know what needs to be done, and then get out of their way and let people amaze them. To fully work DevOps, you must abandon command and control management. Abandon Taylorism. To be DevOps, teams must stop working in silos and work together with a common goal. All the handoffs that silos cause will only slow them down. In this video, you learned that working DevOps means pushing small releases faster in order to gain feedback, minimize risk, and maximize learning. Taylorism was designed for factory work, while software development is like craft work. And handoffs created by working in silos results in mistakes, bottlenecks, and delays. After watching this video, you'll be able to recognize that software engineering is different from civil engineering, describe how software engineering is constantly changing, and describe how the project management model does not work well for software development. A common practice that goes against work in DevOps is treating software engineering efforts as if they were civil engineering projects. For a civil engineering project, you might want to build an office building. So you hire an architect who designs the building and creates a blueprint. The blueprints are handed off to the construction team who follows the blueprints to build the building. Once that handoff is made, the architect moves on to the next project. They may get consulted on some questions about the blueprint, but largely their job is done and they move on. The construction team spends months building the building to the specifications laid out in the blueprints. When the construction is complete, the building's handed off to the maintenance team, who then takes over maintenance of the building. And unless you're in California, the ground doesn't move too much from under the building, and things are fairly steady from that point forward. The problem is, we treat building software the same way. Software development efforts are usually run as if they're civil engineering projects. We view it as a project to be completed and then move on. Architects throw designs over the wall to the developers, and they move on to the next project. Developers throw code over the wall to the testers, and when the project is complete, the whole thing gets tossed over the wall, right, to the operations team to run and maintain it as part of business as usual effort. All the people on the project team get reallocated to new work, and maybe a skeleton development team is left for maintenance. In contrast to this civil engineering approach, software engineering is organic. The software stack under your application is constantly changing, even when the application doesn't. The operating systems are being patched, packages are being updated because of newly discovered vulnerabilities. Right? These changes affect the application. And the operations team has to deal with all these changes on their own. New features are constantly being added. Once an office building is built, you usually don't add new floors. Software is not like this. The behavior of the system is constantly changing. Yet we continue to treat software engineering as if it were a civil engineering project. The project model is fundamentally flawed as a way of doing software development. When a project is complete and people move on, there's no ownership. This is not the way to create great software. You want to treat software development like product development instead. Products have long lives and continue to be enhanced. If instead of moving on, the same team builds and maintains the software, they'll retain a deep understanding of the code and feel ownership for the code. They'll have great ideas on how to make the code better. We must stop treating software engineering like civil engineering projects. In DevOps, we want stable, long-lasting team membership with end-to-end ownership. This is how to create great software. In this video, you learned that software development is often viewed as a project to be completed and then passed on to operations to maintain. Software engineering and the behavior of the system are constantly changing. And team ownership and stable teams make software development more like product development and less like project management. After watching this video, you'll be able to differentiate between traditional ops and DevOps, describe ways Dev and Ops view each other, and list required DevOps behaviors. DevOps presents diametrically opposed views to how traditional enterprises think. Enterprises are built around end-to-end processes that see new as complex, high risk, and expensive and time-consuming. They approach anything new as a one-time project to be completed in a fixed time frame for a fixed budget and then move the people on to the next project. DevOps seeks to turn this on its head, breaking big projects down to deliver a continual series of small changes that are more manageable. Smaller changes to be completed with less risk, so DevOps reduces the risk of large projects. The catch is that small changes cannot survive the traditional overhead that enterprises add to everything you want to do. Processes like change review boards don't work in DevOps because they cannot move at the speed of need for small changes. We have a clash of work cultures between traditional ops and DevOps. In traditional ops, we make manual configuration changes to critical infrastructure. In DevOps, we automate deployment to all environments. This is why traditional ops needs change review boards. Everything is done manually, and humans are fallible, and even if the change is approved, there's no guarantee that it will be implemented correctly. In traditional ops, application architecture is defined by the network design. In DevOps, it's the other way around. The network design is defined by the application architectures. We have software-defined networks that conform to whatever the architecture needs. In traditional ops, bespoke infrastructure is built once and then maintained forever. In DevOps, ephemeral infrastructure is created for new deployments. We don't maintain the infrastructure. We tear it down and replace it entirely. You can't do this unless everything is automated. The manual overhead would slow you down too much. In traditional ops, risk is managed through change windows. Changes are only made at certain times, pre-designated as change windows. That is, no change can happen outside those change windows. In DevOps, risk is managed through progressive activation. We can make a change to the system at any time. We use deployment techniques to activate or deactivate the change as needed. And finally, traditional ops has a process biased towards build once. Traditional ops builds everything manually and maintains it forever, or at least until it's not needed anymore, which is usually several years. Sometimes they build it once and can't figure out how to build it again the same way because the build wasn't documented. In DevOps, processes are re-engineered for high volume, rapid throughput of changes, making builds repeatable, leveraging infrastructure as code to assure that anything we do can be built again. When cultures clash, it's a no-win scenario. Development is measured by how much innovation developers can produce. They keep up with the changing needs of the users by developing and deploying new enhanced capabilities. Operations want stability. They want to ensure that users can use those services and applications and that their data and information are kept safe. These two goals are in opposition. You can't have both. Andrew Clay Shafer called this the wall of confusion that exists between dev and ops. What we need to do is break down that wall. The first step is to change the way development operations view each other. Ops, well, the ops view of development is that development is throwing dead cats over the wall. They manually implement changes, that lack of backout plans, lack of testing, their environments don't look like production environments. And then the devs, they think ops are making these all or nothing changes in the dead of night, in these change windows, and they're the furthest from the code, so they don't understand. Ops is using cut and paste from runbooks, right, from Word documents. Silos breed apathy. You can't have people working in two silos with diametrically opposed metrics. It's never going to work. You must bring these people together. You must give them one set of metrics that add value to the customer. The website works, developers get the praise. The website's down, ops gets the blame. Did I mention the no-win scenario? This is not a healthy working environment. Here are some required DevOps behavior. DevOps turns a number of these things on their head. You need to break down the organizational silos and the handoffs that they cause and move to a culture of shared ownership and high collaboration. There's no hole on your side of the boat. Everyone must see themselves as in this together for a common goal. You must go from fear of change to managing risk by embracing change, managing changes that are small. Big changes are always scary to everyone. Make the changes small and manage the change. Go from building something once, these handcrafted snowflake servers where each one is unique and you could never find another one just like it, to using ephemeral infrastructure deployed using infrastructure as code techniques so that they are repeatable. Every time you build a Docker container, every time you build a virtual machine, build it exactly the same. If you did not change the code, it will be built exactly the same and get the same results. Change from manual fulfillment, ticket queues, and people manually doing things to enabling automated self-service. I've seen companies adopt the cloud and then put a ticket queue in front of it so that only the IT people can provision from the cloud. That defeats the whole purpose of having self-service cloud. Self-service is the way to move quickly. And finally, you must change from alarms and callbacks and escalations to fast feedback loops that are data-driven. And make sure you can get that information about what's going wrong in production and then react to it when you need to. These are the behaviors that must change in order for you to fully become a DevOps organization. In this video, you learned that enterprises see change as complex and time-consuming. DevOps breaks big projects into a series of small manageable changes. Traditional ops builds once and maintains, and DevOps ephemeral infrastructure is created for each new deployment. Dev wants innovation, while ops wants stability. Required DevOps behaviors include shared ownership, collaboration, embracing change, and data-driven responses. After watching this video, you'll be able to define infrastructure as code, describe ephemeral infrastructure, and describe immutable delivery via containers. Infrastructure as code is the practice of describing infrastructure in textual format. I'm not talking about documentation here. I'm talking about a textual format that is executable, otherwise known as code. You want to be able to configure your infrastructure using a textual description that you can give to a tool to execute. The tools that make this possible are called configuration management systems. These are tools like Ansible, Puppet, Chef that allow you to describe your infrastructure as code and then create that infrastructure and keep it in that state. You never want to perform system changes on software configurations manually. This is not reproducible and it's extremely error-prone. You want to use templates and scripts that describe how to install and automatically configure elements such as systems and devices and software and users. Then you can take that textual code and store it in your version control system so that you have a history of all the changes. This way, everyone knows which version is the latest version and how the infrastructure should look. Technology like Docker and Vagrant and Terraform and even Kubernetes also allow you to describe your infrastructure as code, and this code should be checked into version control. The reason this is so important is because server drift is a major source of failure. Over time, servers get updated for various reasons and not always by the same people. This causes them to drift from their original configuration. Sometimes the accumulation of these changes cause failures in unpredictable ways. Even worse is having servers that are supposed to be the same, but one of them keeps failing due to misconfiguration somewhere. The saying, servers are cattle, not pets, refers to how you treat servers. Suppose you have 1,000 head of cattle. You don't take the time to give each one of them a name. When one of them gets sick, you put them out of their misery and you replace them with another. Pets, on the other hand, they're lovingly cared for and nursed back to health when they're sick. The message is not to lovingly handcraft servers or spend too much time debugging when they don't work. You want to be able to replace them with an identical server that is working properly. That means you must think about your infrastructure as something ephemeral or transient. It only exists for the time that you need it, and then you remove it when it's not being used. For example, in the past, building test environments took weeks, so you would keep them around for months because it took weeks to build them. But when you have infrastructure as code, it takes minutes to deploy a new set of servers. So you could bring up a test environment and use it for a period of time and then destroy it. If you need it again another day, create a new one. You don't keep it running forever. You just bring it up when you need it. You bring it down when you no longer need it. It's transient. This also allows us to release through parallel infrastructure. For example, I can build up a server that looks just like the one that's in production, and I could deploy a new version of an application or monitor it, see if it's working correctly. And if it looks like it's behaving correctly, I shut down the one in production, I make the new one the production server. With parallel infrastructure, I can keep things running constantly. Infrastructure as code allows me to create identical infrastructure every time. Ephemeral infrastructure can be used and then discarded because servers are built on demand via automation using infrastructure as code techniques. Tools such as Docker help us create immutable delivery. Docker is a packaging technology that allows us to bring things up and bring them down in a consistent fashion in an isolated environment called a container. Docker supports infrastructure as code by allowing you to specify how to build the image from code called a Docker file. These Docker files build the same image in the same way every time. Docker then creates a container from that image in the same way every time it's deployed. This means that the container is not the one that's running in the production, right? Can run on the developer's laptop. It's the ultimate dev prod parity. This is because time. Docker then creates a container. These Docker files build the same how to build the container. Down immutable delivery. Docker is a packaging technology that allows us to bring things up and bring them down in a consistent used and then discarded because servers are built on demand via automation using infrastructure as code techniques. Tools such as Docker help us create immutable delivery. Docker is a packaging technology that allows us to bring things up and bring them down in a consistent fashion in an isolated environment called a container. Docker supports infrastructure as code by allowing you to specify how to build the image from code called a Docker file. These Docker files build the same image in the same way every time. Docker then creates a container from that image in the same way every time it's deployed. This means that the container is not the one that's running in the production, right? Can run on the developer's laptop. It's the ultimate dev prod parity. This is because all of the dependencies to run the application are packaged together inside the container. This limits any variance or possible side effects. There's nothing else needed except for the container runtime like Docker to run it on. Tools like Docker also allow you to do rolling updates with immediate rollback, right? You're not installing the application to see if it works and then uninstalling it if it doesn't. You simply bring up a Docker container with the new version. If it starts misbehaving, you stop it and bring it down, bring up the previous version, which is already installed in its own container. It literally takes seconds. You would treat containers that start misbehaving the same way. You delete the container, you create another one to take its place. The new container is going to be exactly like the old one on the first day it came up. If there's some kind of corruption, it's going to be clear that the corruption bring the whole thing back down to its original state. This is a different way of working. You never make changes to running containers like you would a running server. Remember, cattle, not pets. You don't patch containers for vulnerabilities or modify them in any way. To make any change, you make a change to the image that the container was created from. Then you redeploy the new container to take the place of the old one. The reason is simple. If you patch a container and it dies, the new one is brought up to take its place, the new container won't have the patches. That's why it's imperative that you modify the image, right? They are the template for creating the containers, and they are the things that must be kept up to date, not the running containers. In this video, you learned that infrastructure as code describes infrastructure in an executable textual format. Ephemeral infrastructure can be used and then discarded. Servers are built on demand via automation. Rather than patching a running container, immutable delivery is making changes to the container image, then redeploying a new container. After watching this video, you'll be able to describe continuous integration and continuous delivery, explain the reason for using small batches in continuous integration, and describe the benefits of continuous integration. People use the acronym CI/CD as if it's one thing, but continuous integration and continuous delivery are two separate and distinct practices. Continuous integration, CI, is the process of continuously building and testing and integrating every developer change into the master branch after a set of tests have passed. The result is potentially deployable code. Continuous delivery, CD, is a series of practices designed to ensure that code can be rapidly and safely deployed to production by delivering every change to a production-like environment. Notice that I said production-like. It doesn't have to be deployed into production, and in fact, many people reserve the term continuous deployment for when you're deploying continuously into production. For continuous delivery, you just have to deploy it somewhere like development, test, staging environment that mimics the production environment. For example, if the production environment is containers running on Kubernetes, you should deploy to a development environment in containers on Kubernetes. Let's start by looking at how traditional development is done. Developers work in long-lived development branches. Typically, they do it this way because older version control systems made a complete copy of code whenever you made a branch. So making branches was very expensive. The cost causes people to resist making branches, and when they do, they don't delete them very often. But with modern version control systems like Git, this is no longer the case. But some development teams have kept the traditional practice. These development branches are kept separate from the release branches and periodically merged into a release branch, but not without lots of breakage. This is because the amount of changes made over a long period of time make the branch more vulnerable to merge conflicts. Builds are run periodically, sometimes nightly, on the release candidate branch. Developers continue to add to the development branch, which drifts further and further from the master release branch. In this scenario, it may take days to merge the code to get it back working. In contrast, continuous integration is a development practice that requires developers to frequently integrate code into a shared repository. And by frequently, I mean daily if possible. This is accomplished by having developers work in short-lived feature branches that are merged into the master once the feature is complete. This means you integrate each feature as it is completed. You don't wait until a long list of features are complete before you integrate them. Each check-in is then verified by automated testing and automated build, allowing teams to detect problems early and often. Once merged, the branch is then deleted and a new branch is created for the new feature. Working in small batches helps accomplish continuous integration. By committing regularly, every developer can reduce the number of conflicting changes because less time has passed between merges. The more time that passes, the greater the risk of merge conflicts. Working for a week on code and then checking it all in at once increases the risk that the new features will conflict with other features. These conflicts can be difficult and time-consuming to resolve. Using pull requests allow team members to communicate about the change they're making. Every pull request is an opportunity for a code review so that other developers review the code. This ensures that all the code is being looked at by more than one person and lowers the risk of something going wrong. Committing all changes at least once a day or once per build is generally considered part of a definition of continuous integration. Speaking of pull requests, every pull request should be built and tested. This should happen automatically. The system should build the changes of the current working version to verify that the integration works correctly. A common practice is to use automation in which a CI tool monitors the version control system and then automates and runs the build automatically. Most CI tools like Travis CI, Circle CI, Jenkins, GitHub Actions, they all have the capability to monitor your version control system for changes as well as automate the build process. Once the code is built, all tests should be run to confirm the code behaves the way the developer expected it to. In other words, make the build self-testing. The test results should feed back to the pull request, and you should never merge a pull request that is failing tests. One of the benefits of practicing continuous integration is that you can get faster reaction times to the changes, and you can move faster. You can move faster because your tests are automated. Since the tests are automated, you know that everything you've done up to that point has been tested and known to work. If you have these tests run automatically, you're not wasting time testing. You're spending your time building features. CI reduces the risk of integrating code because you're integrating smaller changes. When things change less, there's less risk of breakage due to changes. Submitting pull requests puts more eyes on the code and therefore results in higher code quality. Everyone has input on the quality of the code. And finally, you know that the code that's in version control works. Remember, the master branch should always be deployable. I've had students ask me, can I write the test case after I build the user interface? And I tell them, by that time it's too late. You've committed the user interface to the master branch. And if we need to deploy the master branch, we have no idea if the user interface works. You should assume that code that has not been tested does not work. You should never merge untested code into the master branch. The master branch should always be deployable. In this video, you learned that continuous integration is building, testing, and integrating every change into the master branch after tests have passed. Continuous delivery ensures that code can be rapidly and safely deployed to production by delivering every change to a production-like environment. working in small batches, aids continuous integration by reducing the number of conflicting changes. The benefits of continuous integration include faster reaction time, moving faster, and reducing the risk of integrating code. After watching this video, you'll be able to describe a CI/CD pipeline, define continuous delivery, list the 5 key principles of continuous delivery, define continuous deployment, and describe how DevOps manages risk. Martin Fowler defines continuous delivery as a software development discipline where you build software in such a way that the software can be released to production at any time. That's easier said than done. Let's start with what Fowler means by in order. That's easier said than done. Let's start with what Fowler means by in order to be able to release to production at any time. It means the master branch should always be deployable. In order to do that, you need to build and test every change. Building and testing every change is the definition of continuous integration. So continuous delivery requires continuous integration. This may be why people simply say CI/CD like it's one word, because you need continuous integration in place before you can implement continuous delivery. You need a way to know if something will break the build. One way to accomplish this is by delivering every change to a production-like environment. It doesn't have to be the actual production environment, but it should be enough like it so that the same procedure can be used to deploy to production. Along the way, there are automated gates that create a pipeline of checks, such as unit testing, integration testing, quality checks, vulnerability scans, security tests. These tests ensure the quality of the code. When this is all set up, we refer to it as a CI/CD pipeline. Like a pipeline, it's a set of tools where the output of one feeds the input of the other. Let's talk about what's needed to set up a CI/CD pipeline. To start off with, you need a code repository to host and manage all your source code. That's a starting point that initially feeds the pipeline. Then you need a build server to build the application from source code. Most cloud-based CI/CD tools like Travis CI, GitHub Actions provide this for you. Then you'll need an integration server / orchestrator to automate the build and run the quality and other tests. Most cloud-based CI/CD pipelines like IBM Cloud Continuous Delivery will provide an orchestration capability for you. You'll also need an artifact repository to store binaries, the artifacts of the application. This is where your Java jar files and war files, Python wheels, Ruby gems, Docker images, or whatever compiled artifacts have been tested and proven to work. And then finally, you'll need a tool for automatic configuration of your deployment environment. Again, most cloud-based CI/CD pipeline tools will provide a way to automate your deployment. When we overlay continuous integration and continuous delivery on top of the software development lifecycle, we can see that plan, code, build, and test are part of continuous integration, and release, deploy, and operate are part of continuous delivery. These are the two cycles, CI and CD, that feed each other. There are 5 key principles that are at the heart of continuous delivery. The first is built-in quality. The CI/CD pipeline comes into play here because it allows every code change to go through a set of rigorous checks to ensure high code quality. The second principle is working in small batches. Working in small batches is important because smaller changes are easier to test and represent less risk of something getting broken. The third is important to acknowledge that computers are good at performing repetitive tasks, but people, not so much. People are good at solving problems. It's best to automate the repetitive tasks using computers and then leave the problem solving to the people. The fourth key principle is to relentlessly pursue continuous improvement. We should always be looking for ways to improve. That means we need to measure using actionable measurements and then take action when the measurement shows what we can improve. And then finally, the fifth principle is that everyone is responsible. When a build is broken, it's everyone's responsibility to help fix the build. Broken builds hold back everyone from moving forward. I wanted you to be aware of the term continuous deployment. I wish they had called it continuous release to distinguish it from the initials of continuous delivery. Continuous deployment is reserved for deploying to production. You can see by the graphic how continuous integration covers pushing code to version control and automating the build and testing once it's integrated. Then continuous delivery takes over using the artifacts from the build and automatically deploys them to some environment. When we use automation to deploy to production, then it's referred to as continuous deployment. Right about now, you might be thinking to yourself, all this automation sounds risky. How do you manage that risk? DevOps manages risk by increasing the rate of change rather than avoiding change. And it sounds counterintuitive, but here's how it works. In DevOps, deployment is king. Deployment should be painless. You want to deploy early and often. The idea is to build up muscle memory. You deploy your code several times before it goes to production. You deploy it to a development environment. You deploy it to a test environment. You deploy it to a staging environment. You might deploy it to a pre-production environment. Since these deployments are automated, by the time you deploy it to production, you know that it works. It would be unusual for it not to work because computers are really good at repetitive tasks. This is why you don't want humans involved in doing manual steps. Once you automate deployment, the code is going to go to production the same way every time. The second notion is that deployment is decoupled from activation. This may sound strange, but you can deploy code with something called a feature flag. Feature flags turn your code on and off without having to redeploy. You can deploy a feature, turn it on, see how it works. If it's not working, turn it off. Or if it's not ready, turn it off until it's ready, and then turn it on in production. Feature flags have become very popular for decoupling deployment from activation. You can also do waves of activation using blue-green deploys and canary testing. This is where you deploy a new feature, but only send 10% of your traffic to it and monitor if it's working properly. Then you can gradually send higher and higher traffic percentages to the new version until you're happy that it's working, and then send 100% of the traffic. Or, if it's not working, you roll it back. This is also known as zero downtime deployment because at no time do you have the system take an outage, right? You don't have to bring it down to deploy new code. Finally, deployment is not a one-size-fits-all. You need to see what works for the product you are building and for what your customer expects. There are many techniques that can be adopted to fit continuous delivery into your business scenario. In this video, you learn that CI/CD pipeline tools provide a way to automate deployment. Release, deploy, and operate are part of continuous delivery. The 5 key principles of continuous delivery have to do with quality, working in small batches, automation, continuous improvement, and shared responsibility. Continuous deployment is when automation is used to deploy to production. DevOps manages risk by increasing the rate of change rather than avoiding it. Deploy and operate are part of continuous delivery. The 5 key principles of continuous delivery have to do with quality, working in small batches, automation, continuous improvement, and shared responsibility. Continuous deployment is when automation is used to deploy to production. DevOps manages risk by increasing the rate of change rather than avoiding it. You can also do waves of activation using blue-green deploys and canary testing. This is where you deploy a new feature, but only send 10% of your traffic to it and monitor. You can also do waves of using a textual description that you can give to a tool to act extremely error prone. You want to use templates and scripting is because server drift is a major source of failure. Over time, servers get updated for various reasons and not always by the same people. This causes them to drift from their original configuration. Sometimes the accumulation of these changes cause failures in unpredictable ways. Even worse is having servers that are supposed to be the same, but one of them keeps failing due to a misconfiguration somewhere. The saying, servers are cattle not pets, refers to how you treat servers. Suppose when one of them gets health when they're sick, bugging when they think about your infrastructure as something ephemeral or transient. It only exists for the time that you need it, and then you remove it when it's not being used. For example, in the past, building test environments took weeks, so you would keep them around for months because it took weeks to build them. But when you have infrastructure as code, it takes minutes to deploy a new set of servers. So you could bring up a test environment and use it for a period of time and then destroy it. If you need it again another day, create a new one. You don't keep it running forever. You just bring it up when you need it. You bring it down when you no longer need it. It's transient. This also allows gates that create a pipeline of checks, such as unit testing, integration testing, quality of the pipeline. Then you need a build server. Artifacts of the application. This is where your Java jar files and war files, Python wheels, Ruby gems, Docker images, or whatever compiled artifacts have been tested and proven to work. And then finally, you'll need a tool for automatic configuration of your deployment environment. Again, most cloud-based CI/CD pipeline tools will provide a way to automate your deployment. When we overlay continuous integration and continuous delivery on top of the software development lifecycle, we can see that plan, code, build, and test are part of continuous integration, and release, deploy, and operate are part of continuous delivery. These are the two sides an integration server slash a CI/CD pipeline, such as unit test and represent less risk of something getting broken. The third is important to acknowledge that computers are good at performing repetitive tasks, but people, not so much. People are good at solving problems. It's best to automate the repetitive tasks using computers and then leave the problem solving to the people. The fourth key principle is to relentlessly pursue continuous improvement. We should always be looking for ways to improve. That means we need to measure using actionable measurements and then take action when the measurement shows what we can improve. And then finally, the fifth principle is that everyone is responsible. When a build is broken, it's everyone's responsibility to help fix the build. Broken builds hold back everyone from moving forward. I wanted you to be aware of the term continuous deployment. I wish they had called it continuous release to distinguish it from the initials of continuous delivery. Continuous deployment is reserved for deploying to production. You can see by the graphic how continuous integration covers pushing code to version control and automating the build and testing once it's integrated. Then continuous delivery takes over using the artifacts from the build and automatically deploy it to a development environment. You deploy it to a test environment. You deploy it to a staging environment. You might deploy it to a pre-production environment. Since these deployments are automated, by the time you deploy it to production, you know that it works. It would be unusual for it not to work because computers are really good at repetitive tasks. This is why you don't want humans involved in doing manual steps. You turn it off until it's ready and then turn it on in production. Feature flags have become very known as zero. Provide a way to automate deployment. A way that the software can be released to production at any time. That's easier said than done. Let's start with what Fowler means by in order to be able to release to production at any time. It means the master branch should always be deployable. In order to do that, you need to build and test every change. Building and testing every change is the definition of continuous integration. So continuous delivery requires continuous integration. This may be why people simply say CI/CD like it's one word, because you need continuous integration in place before you can implement continuous delivery. You need a way to know if something will break the build. One way to accomplish this is by delivering every change to a production-like environment. It doesn't have to be the actual production environment, but it should be enough like it so that the same procedure can be used to deploy to production. Along the way, there are automated gates that create a pipeline of checks, such as unit testing, integration testing, quality checks, vulnerability scans, security tests. These tests ensure the quality of the code. When this is all set up, we refer to it as a CI/CD pipeline. Like a pipeline, it's a set of tools where the output of one feeds the input of the other. Let's talk about what's needed to set up a CI/CD pipeline. To start off with, you need a code repository. After watching this video, you'll be able to define continuous deployment and describe how DevOps manages risk. Martin Fowler defines continuous delivery as a software development discipline where you build
Welcome learners to Introduction to GitHub and Visual Studio Code. Today I will be your instructor, and by the end of this project, I would have introduced you to two useful software tools to becoming a developer, GitHub and Visual Studio Code. Throughout this project, you will follow alongside of me screen to screen to complete a variety of tasks. You will create and learn the value of GitHub profile. Your GitHub profile, you will provide hosting for software development and version control using Git. You will also learn how to link your GitHub profile to your Visual Studio Code. So this is Visual Studio Code, which is one of the softwares for which we'll be using today. This is GitHub Desktop, which allows you to connect your online GitHub profile to your Visual Studio Code. Visual Studio Code will act as your source code editor, for which we will link to your GitHub account that we'll create in Task 1. Remember, Visual Studio Code and GitHub are a great way to hoist your projects when developing. Now let's proceed with Task 1. Now we are going to practice. Once you create a GitHub profile, you'll be able to continue to the next task. Once you have Google Chrome open, we're going to type in github.com and then go to the sign up section, which should appear directly on your home screen. You create a username. Since usernames can't contain certain aspects, my username is going to be Teacher Coursera. Then you're going to enter your email. Now that you have your email typed in, you're going to create a password and sign up. You're going to have to verify your account. Once you get to this step, it's going to say, welcome to GitHub. They're going to ask you, what kind of work do you mainly do? You can choose whichever icon you want. I'm going to choose teacher. How much programming experience do you have? I'm going to enter a moderate amount. Please answer according to what skill set best fits you. What do you plan to use GitHub for? Learn, host. I chose the top three. Once again, please choose whatever fits you. And what languages am I interested in? CSS, HTML. Once you press enter, they're going to ask you to verify your email. So I'm going to resend my verification code. And I ask that you pause here in the section. Your search section allows you to search other people's repositories or other people's projects. People do not always work from their own code. Sometimes they use templates of other people's projects to get things started, for which you can search directly here. The next button you see here is your pull request. It lets you tell others about the changes you have pushed to your GitHub repository. Once a pull request is sent, interested parties can review the set of changes, discuss potential modifications, and then push the following up commitments if necessary. The button after that is your issues button. You use your issues to track ideas, enhancements, tasks, or bugs for work done on GitHub. Following that is the Git Marketplace. It is a new way to discover and purchase tools that extend your workflow. Next, we have the Explore button. This repository houses all of the community's curated content for GitHub, topics, and collections. Then we have our notification button. Next, we have our plus sign. Our plus sign allows us to create new repositories, import repositories, new Gits, new organizations, as well as new projects. Following that, we have our icon, which is your user. It allows you to see your profile, which looks like this. Your profile establishes a pattern of how many commitments you make per day. So today we have one contribution. It also will populate your repositories right here as you create them. Then you have your repositories, which is where all your different projects will go. You have your projects, which is collaborations you do with other people. They will generate there. You have your favorites and other features such as upgrade, featured preview, help, and settings. Now that you have had your GitHub info session, you're clear to move on to task 3. GitHub will act as your online host and place to save your projects and develop a collection for your portfolio and all your work in the near future. Great job on completing the first part of this project. In this task, we will learn about how to create a repository. Creating a repository should pop up as an option for what you would like to do first. But if this does not happen for you, there are two options to create a repository. Right here on your left-hand side, there is a green button that says Create Repository. And if you choose not to go with this green button, like mentioned before, here's a plus sign that also allows you to create a new repository. Once in the new repository window, you will start by naming your repository My New Repo. From there, you'll proceed to your description. It is optional, but it's always nice to have a description of what your project will entail. Connecting VS Code to GitHub. That's a good description for starters. We're going to make this repository public so that potential employers and contributing developers may see your work. I recommend that you initial your file with a README for best practices. This is where all the description as well as the preview and the demo will go for people who are viewing all your work. Now, click Create Repository. This is where your README will populate in your repository. Having a README is important when making a project because a description of what your project is about will go here. This will be the first thing people see when you click on a person's project before actually looking into the folders. This entire area here is called your repository. Repositories are large folders on your GitHub profile that host smaller folders that contain code. The smaller folders that contain code will populate in this area right here. Seeing how you have no code at the moment, the only thing that's populating is your README. If you proceed over here, we have the code button. This button is very important. When you click on it, it gives you options to open in GitHub Desktop, which is what is on our desktop right now, or download a zip. When you download a zip, it's like saving a file to your computer. By saving this file, you are allowed to open your code to Visual Studio Code, but you have to go through your terminal of Git Bash. GitHub Desktop allows you to easily transfer your code from your GitHub webpage to your Visual Studio Code. Next to it, you have Add Files. Add Files allows you to upload new files or create a new file. Remember, I mentioned to you that you don't have to always code from your own initial project. You can upload templates in different files to empty repositories. Files cannot be uploaded unless your repository is empty. Next to this, you have the Go to Files button. When you click Go to Files cannot be uploaded unless your repository own initial project or create a new file. Remember, I mentioned to you that you don't have to always code from your own initial project. You can upload templates in different files to empty repositories. Files cannot be uploaded unless your repository is empty. Next to this, you have the Go to Files button. When you click Go to Files, it'll allow you to go to an area where your different files generated through your code will populate. Let's take a step back. Next, you have the main. So you can code from different branches. Since you aren't contributing with anybody, you'll be on the main branch, which is your initial branch. Up here, you have the code button, which allows you to be where your repository is. Next, you have the issues button. You have no issues at the moment because you haven't started coding yet, but typically this is where any bugs will populate. Pull request button, which will come from different contributors on your project, asking you to approve work or you to approve their work. You have no pull requests at the moment. You also have actions. Actions is where GitHub calls things to your attention. Then you have projects, which is things you work on with multiple developers. You have wiki. You also have security, which is your settings for your project. And you also have insights. So let's go back to our code. I just want to bring something else to your attention before we continue. We just made our first repository. We're going to go to our profile. As mentioned before, when you create a repository, your comments get populated here. So far, you have 3 contributions as of today, which essentially shows your history. And then if you scroll down, it says that you created your first repository and you created 1 comment to this repository so far. And now this repo has generated into your popular repository section. Welcome to task 4. In this task, we will pick up from where we left off, and we will clone the repository to our desktop. This allows you to host your work locally. To host our work locally, we're going to use GitHub Desktop. To do that, we're going to minimize our browser and locate our GitHub Desktop icon on our desktop. Then we'll proceed to double-click GitHub Desktop. GitHub Desktop is a fast, easy way to contribute to projects from your desktop. GitHub Desktop is designed to simplify all processes that the window flow in your GitHub, and it acts as a great way to connect to your Visual Studio Code as well. Once you have your GitHub Desktop icon open, we're going to sign into our GitHub. You start by typing in your username. Then you proceed to type in your password. After that, you sign in. You should see your configure Git pop up with your name as well as your email. As it relates to your GitHub account, and you're going to press continue. Make GitHub Desktop. Now finish, and this is what the GitHub Desktop looks like. In order to connect our repository to our GitHub Desktop, we are going to click right here to clone repository. There's another method in which to clone your repository as well, which you can do directly from the web browser. You go to Code, open in GitHub Desktop, which will ask you to download GitHub Desktop, but since you already have it on your computer, you don't need to download it. We're going to minimize that. Click the repository for which we want to clone and proceed to clone our new repo. This box will pop up to make sure you're sure you want to clone, and you're going to press clone again. Welcome to your GitHub Desktop. Let's take the tour. In our GitHub Desktop, we have a navigation bar that consists of File. File is a location where you can create a new repository or clone a previous repository, which is linked to your GitHub account. Next, we have Edit. Edit is a location for which you can undo and redo items, as well as cut, copy, and paste, and select all, as well as find. Next to that, we have Views. View is a section where you can get the history of all your changes, as well as your repository list and your branch list. Next, you have Repository. This allows you to push and pull, which is a method for gathering all the information that's on your GitHub and pushing all the information from your Visual Studio Code back up to your GitHub. Next, you have Branch. You can start multiple different branches within a singular project, and Branch is the tab that allows you to maneuver through that. Last but not least, you have Help, which allows you to report an issue and fix any bugs that you may have. To the left over here is where your changes and the history of your changes will populate. As you are making changes to your code on your Visual Studio, those changes will populate in this section right here. You have the option to save your work directly within your GitHub Desktop by writing a summary and a description of what you did and then committing it to your main, which is your GitHub host online. or you have the option of saving it within your terminal directly on your Visual Studio Code. This section over here, which is the center section, is where your current repository for what you're working on will be held. You can use this button, which is the view on GitHub, to see your repository on your github.com. So it brings you here. Or you can show it in your Explorer, which shows you what your project looks like in your folders on your computer. Now that you've had a tour of your GitHub desktop, I would like for you to keep in mind that GitHub desktop is used as a buffer to connect your GitHub profile to your Visual Studio Code. Your GitHub profile acts as your online host for your code, whereas your Visual Studio Code acts as your local host, which is directly on your desktop. I want you to think of your GitHub desktop as the middle buffer that connects these two items together. Great job on the last task. In this task, we will be cloning our project into our Visual Studio Code. By the end of this task, you would have learned how to clone a repository into your Visual Studio Code, as well as what the different sections of Visual Studio Code are. Now that you have successfully cloned your repository into your desktop, you will proceed by clicking the Open in Visual Studio Code button. Your repository will open in Visual Studio Code. Now that we're in Visual Studio Code, let's take a quick tour. This main section here is called your editor. And you can open as many editors as you want by clicking the Split Editor button. This is useful when coding CSS as well as HTML. This side area here is called your sidebar. Your sidebar contains different views to assist you while working on your project, like your Explorer. This lower area of your editor is called your status bar. This gives you information about what you are working on, such as your project, the last time it was synchronized, whether or not there are any problems going on, which you have 0 because you don't have any code. Then you have next to your sidebar these 5 icons, 1, 2, 3, 4, 5. They contain different views to assist you while working. This section is called your activity bar. The activity bar includes, but are not limited to, your file explorer, your search across, your source management, launching and debugging, as well as extensions. The activity bar lets you switch between views and gives you additional context indicators, like the number of outgoing changes Git is enabled. I specifically care for the extension section because it allows you to search up different extensions to make your coding process easier as well as more intuitive. In the top area, you have the navigation bar. Underneath File, you can open new repositories and load new folders onto your editor. In the Edit section, you can undo and redo as well as copy and paste and replace different things within your code. In the selection section, you have extended selection, you have copy a line, you have add a cursor above, things that help you when coding your project. In the view section, you have your command palette, you also have your appearance, how you want your editor to look, how do you want your editor layout to be. You can also debug your console. I like toggle word wrap. It allows for wording to wrap around and so that it doesn't go off screen when you're working. Then you have the Go section, which allows you to switch between your editors. Like I told you before, you can have as many editors open as you want. You have the Run section. The Run section is very important for when you're debugging your project. You have your terminal. Your terminal opens a section here at the bottom of your editor that creates different panels. Right now you're in your PowerShell panel. I mainly work inside my Git Bash panel because it allows for easier saving. And then all you need to do to get your Git Bash panel is click plus sign. You can split between these two screens as well. You don't have to have a bash and bash. You can have a bash and PowerShell. There's different ways to go about it. Last but not least, you have the help section on your terminal, and this gives you notes about how to use Visual Studio Code, notes about licensing, as well as tips and tricks on different ways you can best utilize your Visual Studio Code. Just a quick recap. To clone your repository, you open your GitHub desktop, Once your GitHub desktop is open, you have the option to clone repository. Once you clone your repository, you click Open in Visual Studio. Once you have your repository open in Visual Studio Code, you can proceed to your coding. You've gathered an understanding of what Visual Studio Code is and how the different buttons and sections work, and now you are ready to begin your coding process. Great job in task 5. Welcome to task 6, coding in Visual Studio Code and saving to GitHub. By the end of this task, you will be able to write code in Visual Studio, as well as add, commit, and push the code you wrote from Visual Studio to GitHub. We are going to write some code, and we're going to save our code to GitHub to the actions of adding, commenting, and pushing. To begin, we're going to put our cursor in our sidebar section, and we're going to hover over the no files. We're going to click that, and we're going to type in index.html to create an HTML document. As you can see, index.html has popped up in our editor. Now we can click directly in our editor and begin to type in some code. You don't need to know code to do this project, so the HTML that we're about to use is a simple doc script for essentially establishing words on a web page. We're going to start with a doc type script. So when you press shift for this symbol, doc type should populate and you can just click on it. After you get your doc type HTML, you press enter, you copy the same symbol again, and you type in HT. HTML will pop up, press enter. Then you close it with the opposite facing symbol. Then a closing tag will populate. Press enter. Inside of your HTML, you're going to start by starting with the same symbol once again, but now we're going to choose body. Press enter, close your body tag, press enter again. Following the word body, we're going to start with a H1. H1 is a tag for heading 1. Close your tag, an end tag will populate. Inside of your heading 1, you will type in my first project. Next to the closing H1 tag, you're going to put in parentheses this is my header. And you're going to press enter again to drop your cursor down. And you're going to create a P tag. A P tag is for paragraphs. Follow the same protocol for creating a P tag. You're going to type in my first paragraph. Outside of the closing P tag, you're going to put in parentheses again, this is my paragraph. Enter. Now that we have some code established in our index.html, we're going to go to our activity bar, to our extension section. In the extension section, we're going to type in live server and launch development. So this is the live server that should pop up, and we're going to install this. Remember, I mentioned that you can install different properties to make your coding process more intuitive and interactive. So we're going to use our live server to view our code online. You start by right-clicking your cursor over your editor and click Open in Live Server. Now you can see my first project, and this is my header populates under my first project. In my first paragraph, this is my paragraph populates underneath my first paragraph. We're going to minimize this, as well as minimize this and minimize this. Just some friendly reminders, we do have GitHub Desktop and Visual Studio Code directly on our desktop. Now we're going to return to our Visual Studio Code and our GitHub Desktop. Before we save our content directly in our Visual Studio Code, I wanted to show you where our source control recognizes that we make changes to our index.html, but that also populates here on our GitHub Desktop as well. So you have the option to save your work in your GitHub Desktop right here, or save your work in your Visual Studio Code. I'll show you both methods. To do it in your Visual Studio Code, we're going to go to our terminal, and we're going to go to our bash section of our terminal. We're going to type in git add, period. And we're going to type in git commit -m quotation marks index That saves our changes, and then we type in git push. A login to GitHub will pop up. So you just proceed to log yourself in. I'm going to do that off camera. Once you log in, all your work will be pushed to your GitHub. And if you go back to your GitHub desktop, as you can see, there's no longer any more changes to be pushed. From here, we're going to go view on our GitHub website. And if you look down, you can see all the changes you've made have been populated into your repository. You can check more by clicking into your index.html, and you'll find the code that you created. So remember, to save your work from your Visual Studio Code to your GitHub profile, all you need to do is git add, git commit, and git push. Thank you for joining me for this guided project. I hope you learned how to maneuver through GitHub as well as Visual Studio Code as a new developer.
Welcome back to Linux Fundamentals. In this video, I want to walk through the lab we talked about this week. All right, so in week one, I'm just going to scroll down to our lab. scroll down to our lab. And here you'll see there's several commands we talked about. So go back to the slides. So in the first reading for this week, I've got a copy of the slides that I used in the lecture. And I pulled out commands that you can do in our cloud version of Debian Linux. So when you click the Open Lab button above, it's going to open up a Debian command shell, or it's actually going to open up VS Code, which is an editor, and we can get to a command shell from there. So if you don't see the terminal, go to the menu and say New Terminal, and you can get to a terminal. And then try these commands, and I'll do them with you. Make sure you try some of the options we talked about. Now, we haven't done very many options in this first week, but as we do this in future labs, we're going to build up your skill set, not just of new commands, but additional options with the same commands. So I'm going to click the Open Lab. This will open a new tab, and the lab will come up. OK, so if you don't see the terminal, you can go to Terminal, New Terminal. You can also make the terminal bigger by stretching it up, or you can say View, Appearance, and you can turn off the Show Editor area to give yourself a full editor. So VS Code is a nice cloud-based open source editor. It doesn't come in the standard shell with Linux, so we didn't talk about it in this course, but it's nice in an environment like we're using here. But here I just want the command terminal. All right, so let's go through some of these commands. I'm logged in as a user called Coder, and you'll see in my prompt, it's got my user Coder, and then at my location, and then my path and prompt. Okay, so pwd is the first command we talked about. If I type that in, this is going to return the path of the current working directory. My path is home Coder. Okay. If I use a cd and I ... that's going to go back a directory. If I do pwd, you'll see home. Now you'll see in the prompt it tells me the path. The $ here means home, my home directory for my user. Okay. I can cd space into the Coder directory again, and I need to spell it properly. And now I can move forward and backward. Okay. The ls command is going to show us the files in my directory. If I want to cd ... I'll go back to home, I'll say ls, and I'll just see the folder or directory for Coder. If I say ls-r was the option we used, that will show me the files inside the subdirectories. That's a very useful command. Now, if you've got a lot of directories and they're very deep, you're going to get a lot of information. So we'll talk about how to deal with that a little bit later on. I'm going to go back into my home directory. And if I say ls-a, it's going to show me the hidden files. So any of these files that have a dot as the first name, so .bash logout, .bash rc, .bash config, .bash local, .bash profile, they don't show up when I do ls because they're hidden. So the -a allows me to see it. ls-al is going to give me lots of information. So the L is long listing, and A says show me all the hidden files. So this is the typical way I do a directory, because I want to see all the files. I don't want you to hide any from the operating system. Okay. Now, the cat command allows me to output information. So I'm going to cat dot profile. And it sends the output from the file to standard out. Okay. We're going to talk about redirection. I had a little bit in the lecture here where I can create a new file. So I'll do that here, but we'll talk about it more. So I'm going to redirect file2.txt from the cat. So instead of sending to standard out, I now have a file called file2. I can cat file2, and I have the same contents. Okay. I can copy with a CP. And now I've got a file2 and a file3. I can move. Now move is funny because it's also rename. So I'm going to rename file3 to file4. And now when I do my listing, and I may be going too fast, remember you can pause and go back. And I can make a directory. I'm going to create a directory called Aspen. Spell my name right. Now if I look, I've got a directory called Aspen. I can change into Aspen. If I do pwd, I'm now home Coder Aspen. If I just do cd, that brings me back to home. And now I want to remove Aspen. And if I want to remove all the files, I can do -r. Now there aren't any files in here, but I'll just do it. And now Aspen's gone. My family wishes they had the rm-r Aspen option to remove me. All right, that's it for this lesson. So I'll do that here, but we'll talk about it more. So I'm going to redirect file2.txt from the cat. So instead of sending to standard out, I now have a file called file2. I can cat file2. Welcome back to Linux Fundamentals. This is the first course in the Linux Foundation